All right, no. Uh, right, okay. So then, give me 1 minute maximum. We'll start within 1 minute. I think I shared the PDF in the group. You can refer the PDF. And today we are starting Unit 1, Unit section. That's the plan. Okay, right. Okay. Okay. We'll start the idea now. First story is now is the idea. Okay. Then right. Then today we are starting the lesson. The first advice I want to tell you is right. Now you decided to do maths or science subject. That doesn't matter. Right. Once you engaged, if you committed to do something, put your 100% focus and 100% give your commitment and do that story. Okay. So don't, whatever time you spend right now, please spend it effectively. That is the important thing you want to understand, right? So then we'll start the idea, but generally we are doing the classes via Zoom. But since this is our first class, we'll stream via the YouTube. The problem is sometimes if you have to clarify some doubts, if you want to ask doubts, then you are facing a struggle. I understand. In that case, what you can do, you can put a message in the YouTube chat. If you feel very uncomfortable of putting a message in the YouTube chat, then you can ask your doubts via my WhatsApp number also. So therefore, I will write my WhatsApp number. If you have any doubts to be clarified today, I think it's not a big lesson. It's a very normal basic lesson, right? In case if you have any doubts, even every section in the lesson, then you can ask your doubts via the WhatsApp. If not, you can put your doubt in the YouTube chat also. It's up to you. It's up to you, right? That story. Then this idea, right? So my WhatsApp number, you can put a WhatsApp message if you have anything to be clarified, right? 0. Right, okay. Then the TUT PDF is already shared in the group. Then I think if you are in the group, definitely you can get the PDF version of the TUT. That story. Okay. Then we'll start the idea. First lesson is units and dimension. Right? Okay. Last week we gave a small introduction, but today only we are starting the lesson. Right? Anyone at any level, if you start working from today properly, definitely you can learn everything properly, and definitely you can reach the goal that you already planned. Okay, so therefore remember, what is your goal today, what is your motive today till the last day of your AL exam. Keep that motive, keep that goal. Never fluctuate the goal with the time. Your goal must be a fixed goal. Unconditionally put your 100% commitment and start working with me. That's what I can tell, right? If you put your unconditional commitment, definitely getting at any result is not a big deal. You can go for the any result that you plan. Everything is possible. It doesn't matter what is your level right or no matter. Your level is A or B or W, doesn't matter. If you we have the time, if you put your 100% commitment and if you start working, everything, anything is possible. That story. Okay, no, now idea, right? Now idea. Then when talking about this lesson unit 1 in your syllabus, we can divide the syllabus unit 1. We can divide into 3 subsections. Okay, 3 subsections. I hope most of you have taken the printouts also, right? Unit 1. There are three subsections. There are three subsections. Number one is units. Today we are talking units only. This is really easy section. And we don't have that much extreme calculation in this section, very basic section. Number two, dimensions. Dimensions. Comparing with unit section, dimension section is somewhat complex, not that much complex. Dimensions. Then only we talk about a practical section. There are 4 practicals in measuring instrument section. Right, vernier caliper, micrometer, gauge, spirometer and traveling microscope. We talk 4 practicals. It's a practical section. That is measuring instruments. Measuring instruments. Measuring instruments. These are the main 3 subsections in Unit 1. Measuring instruments. 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 Okay. And also we talk another subsection that is called errors. It's not a big section, but we can take it as a separate section also. Errors. Errors is the overall idea. Okay. Unit 1 is really not a difficult lesson. Anyone at any level can understand this lesson. Unit section is very basic story. Okay. Right. Okay. Then take your tudes and in the PDF, first of all, you want to understand what is a physical quantity. What is a physical quantity? First section. First story. If you want to clarify anything, if you have to ask doubts, then you can put a message in the WhatsApp number. You can put a message in the WhatsApp number, right? If you have anything to be clarified, put a WhatsApp message only for today, right? Because if you feel very uncomfortable in the YouTube chat, put a WhatsApp message, then I can go with your doubts and I can clarify your doubts and all. Right now? Okay. Then first story. First story now, measurements. This is not something very new for all of us. No? In our everyday life, we are obtaining plenty of measurements, right? Just now also, before coming to the class, you took a measurement, right? Before coming to the class also, everyone who joined the class right now also took a measurement. What was that measurement? You all watched the time, no? So you know that the class is starting exactly at 7 p.m. Right? Actually, you were counting the time. You were counting the time till 7 p.m. 6 p.m., 6:30, 6:45. So likewise time, you took the measurements of time. Likewise, in our day-to-day life, we are obtaining plenty of measurements. We know the length, distance, time, sometimes we measure the mass. So therefore, obtaining measurement is not a big story for us, no? Since our childhood, we are really used to obtain measurements. But basically what we are measuring what? We are measuring physical quantities. Right? We are measuring what? Measuring physical quantities. Then we should have an idea about what is a physical quantity, no? What is then? So then what is a physical quantity? Then what is a physical quantity? Then we are starting from there. Starting from there, first story. Starting from the story. Right? This is 100% theory section. Okay, it's all about theories, some stories and theories. Physical quantities. Physical quantities. Physical quantities. What is a physical quantity? So we can define physical quantity as any quality or quantity if you can measure directly or indirectly. That is what we call as a physical quantity. Any quality or any quantity if you can directly or indirectly measure it, that's what we call a physical quantity. If not, I can explain story in other way. Whatever the changes happens in the universe, whatever the changes happening in the universe, if you can measure it, then we can give a name for that change as a physical quantity. Right? Right? What is a physical quantity? Because we know that around us, the surrounding, we experience plenty of things are changing. Whatever the changes happening in the surrounding, if you can identify that change and if you can give a name for that change, that is going to be physical quantity, right? For example, we all know that, for an example, I'm telling some examples. Now, you all know plenty of examples, physical quantities, you all know, but just I'm telling. Now, you are observing, look at the first story. Whatever the changes happening in the surrounding, if you can identify the change and if you can give a name, if you can measure the change, that is going to be physical quantity. For an example, let's say now, that's a person. That's a person, for an example. This person, right, initially standing at point capital E. There's a person. This person is standing at point capital E initially. Then you are observing the person. You are observing the person. You understand this person is under motion. This person is moving. Right? This person, earlier person was at point capital A. Now you observe the person. You are focused on the person. This person is moving. Person is moving. Then you see when the person is moving, you are feeling, you are observing kind of change. As a human, you are observing a kind of change. Right? Right? Initially, person was at point capital A. A person is moving to the right side. Okay? Person is moving to the right side direction. Now, person is at point capital B, point capital C. So, you're observing kind of something is changing in the person. If you can give a name, what will be the name that you give? Better if you can put some replies also better. Now, you are observing a change happening in the surrounding. When you are observing the person, you see something is changing in the person. If you can give a name for that change, what will be the name that you are going to give? It's going to be a distance, no? Distance. When the person is traveling, we experience that person's location changes. When the person's location changes, if you can measure that change in location, if you give a name for that change, that's going to be distance. Right? So then we understand distance is a physical quantity. Likewise, we can tell that now I'm standing. No? I'm standing and I'm waiting for someone. I'm standing and I'm waiting for some time. Then I experience that something is changing. Right? I'm waiting for someone and I'm experiencing a kind of change. I can measure something. Right? That is time. Okay? So likewise, remember, every change happening in the universe, if you can measure it, it can be qualitatively. If not exactly quantitatively, if you give a name for that change, that's going to be a physical quantity. Idea clear? No? That's the basic idea. I think idea is clear. Simple idea. So write down in the tute, take your tutes and step by step you write the ideas. If you want to ask doubts, you can ask via the Zoom chat, YouTube chat. If not, you can put a WhatsApp message. This is my WhatsApp number. Right? First story, write down in the tute. Write down the tute first story. Write down. Under that tute, write down first story. Now, in the tute page number 1, I mentioned that in modern society, measurement is essential to carry out any task in an organized and planned manner. Here the space is measured. That is, the 3 basic measurements made here are, now mostly, we all know that mostly there are 3 measurements that we take. One is we are measuring the mass, and then the length, and the time, right? So therefore we can tell this mass, length, time, they all are physical quantities. The main 3 measurements that we take in our day-to-day life is mass, length, and time. Therefore, in the given space, write down number 1 is mass. Number 2, write down. Number 1, mass. Number 2, write down. Number 2, length, and number 3, time. These stories you all know, but we'll learn from the beginning. Mass, length, time. Right? So then our main topic is physical quantity. Different color pen write down. Write down under physical quantity, write down different color pen. A quality of quantity, a quality of quantity, a quality of quantity, write down a quality of quantity that can be measured directly or indirectly. A quality of quantity that can be measured directly or indirectly. A quality of quantity that can be measured directly or indirectly is defined as a physical quantity. Is defined as a physical quantity. Is defined as a physical quantity. A quality or quantity that can be measured directly or indirectly is defined as a physical quantity. Right? Okay. So then remember, we can give plenty of examples, physical quantities. Give some examples. What are the examples that you can give for physical quantities? Yes, mass is one physical quantity. Length is the main physical quantity. And time, right? Very, very important physical quantity. What are the other physical quantities that we can explain? Mass, length, time. One can tell speed, distance, displacement, velocity. You can calculate, you can measure the velocity, right? Different vehicles have different speeds. Nahi? Acceleration, right? Generally we are asking some doubts and we are going through the session, but today we are doing this way. But don't worry, very soon we'll shift to the Zoom method, okay? Only today and most probably next week. We are going in this YouTube way. Other than within 2 weeks, we are shifting back to our usual Zoom setup and we are studying. Then it's easy, right? You can ask your doubts and I can clear your doubts. Then it's really engaging, no? Right? So then give some examples of physical quantities. Examples, we can tell examples. Plenty of examples are there. So number one is mass. Write down in the below. In the given some, I think you can find some space. In the below space, write down mass, length, and in time, they all are physical quantities. And in speed, distance, someone can tell displacement, speed, and acceleration, velocity, density, pressure, force, energy, linear momentum, density. Then the pressure, energy, force. Just write some examples. Force and volume, area. These all comes under physical quantities. These all comes under physical quantities, right? So then we know what is a physical quantity. Then we know the examples of physical quantities. Next idea, right? Temperature, yes, temperature, yes, temperature. Important physical quantity, temperature. Oh yeah, likewise, you can tell plenty of examples. You can tell plenty of examples for physical quantities. You can tell like that, right? Right, okay. That story. Now, okay, right? So now, right, we understand lots of changes happening in the surrounding, and also we realized those changes, if we can measure it qualitatively or quantitatively. What do you mean by changes measuring qualitatively or quantitatively? Right, for an example, if we take a physical quantity, let's say we'll take the physical quantity length, if not height. Let's take a physical quantity height. Right, height. Okay. Now there are two persons standing nearby. Right. Then there are two persons standing nearby. You want to calculate, you want to check their heights. If you are expressing their heights qualitatively, how do you express? There are two persons standing nearby. The physical quantity you selected to analyze is the height. Physical quantity, height of the person. There are two people. This is person A, right? And if I do the person B, this is the person B. Person B. Okay, no? Person A, person B. And now I want to measure the height. I want to measure their heights. Then I can explain their heights qualitatively. If not, I can measure their height quantitatively also. Right? Let's say height of person A is, let's say HA for an example. HA. And height of person B is, let's say HB. Height of person B, let's say HB. HB. How do you represent the physical quantity height in a qualitative manner? Qualitative. You can tell that person B is taller than person A. If not, you can explain person A is shorter than person B. If you represent their height qualitatively, you want to use shorter, taller. But you don't know exactly what is the height of A. You don't know exactly what is the height of B. You don't know what is the deviation. What is the height difference between A and B? You don't know. So when you are measuring qualitatively, that's the problem. You can tell relatively. Relatively, this one is taller. Relatively, this one is shorter. You can't think beyond that. That is the idea regarding qualitative measurement. Qualitatively, if you measure it, qualitatively, if you are measuring qualitative measurement, you can tell tall, short, such words. Tall, short. This object is heavier than that object. This object is lighter than this object. Right? Shorter. Then how can I express the height of these two people using quantitatively? Quantitatively, how can I measure the heights? Quantitatively. Right? Then this time, I should accurately. Exactly, I want to measure the height. Now, we all know that to measure the height, we can use the unit called meters. But I will teach you, I want to teach you why are we using meters, right? But to explain the quantitative meaning, I will use the unit meters. But again, I will go from the beginning and I will explain what is meter. So if you say that, sir, the height of the person is for example 125 centimeter. For example, if you are measuring using a unit, I will tell you, if you are measuring the quantity exactly height of the person is 125 centimeter. Height of the person B is 150 centimeter. Then that's a kind of quantitative measurement of the height. Quantitative measurement of the height. Clearly, you can tell, for example, height of the person is exactly 125 centimeter. Now, this unit story I will teach you. Height of the person B is exactly 150 centimeter. This is the difference. Then the idea is clear. What is a physical quantity? Idea clear. Then physical quantity examples also, we have plenty of examples. Then we talked about what do we mean by qualitative measurement, measuring a physical quantity qualitatively and measuring a physical quantity quantitatively. The difference also I explained right now. Then we'll talk about our main story units. Right? Okay. Then okay. That story is okay, sir. Now, right, okay. Now, next story. Next idea. Right? You can write on, if you want, in the TUT somewhere else, write on the stories also. The difference between qualitative and quantitative idea also important. No? Therefore, if there is any space nearby the TUT, just write these two stories also. And now only, why do we need units? Units. Right? Why do we need the units? Okay. Now, we all agree that we should measure physical quantities. When measuring physical quantity, why do we require units? That idea. Next story. Next story. Next story. Requirement of units. Go to the page number 1, and in the tutor I mentioned requirement of units. I mentioned presenting only the magnitude of a physical quantity does not give a clear idea of the physical quantity. It must be presented with a unit in order to have a clear understanding of the physical quantity, right? For example, let's say now you are measuring the height of the person A, right? You are measuring the height of the person A. Now you are measuring using feet. We all know feet, that is also a unit to measure the height, no? So what you are doing, you are using your own unit system, right? We don't know. You are telling that height of the person is, you are saying now there are two people. Now I'm asking from both of you, measure the height of the person A. What you are doing, you are saying that height of the person A is 2. Height of the person A is 2. Another one is saying height of the person A is 100 and let's say 95. Now if I ask to measure the height of the person A, one is saying height of the person is 2, other one is saying height of the person is 195. Now then I'm really confused, right? Now, what do you mean by what do you mean by 2? What do you mean by 195? Right? So you are using some your own methods to measure the height. One said 2, another said 195. That's a problem, no? So the problem means the third party can't identify exact this magnitude. Why one says height is 2 and why other one is saying height is 195, the third person can't understand it clearly, no? So therefore we all know that when we are measuring a physical quantity, we should use a unit system that all of us are aware, right? If someone mentioned the height of person is for example 2 feet, for example, if someone mentioned height of the person A is 195 centimeter, for example, then they understand, right? Okay, why it is 2 means 2 feet. That's why it's 2. This person is measured the height in centimeter. That's why it's 195. Therefore, very clear, we require a unit system also to measure any physical quantity, right? Then we can go to some history and we'll talk earlier how they measured the physical quantities. Then what was the problems there? Then what they have done, that story we'll talk right now. Okay, stay focused. Every point matters. Today it's all about a story. Today, if it is possible, we can do some questions. Today it's all about talking stories. Okay, stay focused and learn. Stay focused and learn. Stay focused and learn. Right? That story. That story. Okay. Next story. Next story. Next idea. Right? If you feel something is important, quickly mark these ideas. Right? I think everything is included in the tute, but if you feel something is important beyond that, what you do, immediately you take your rough piece of papers and put in your papers. That's better. That's better. Right? Okay. This idea. Then when we go to the ancient times, a small history. Now we realized there are physical quantities. We want to measure them. Physical quantities, they have magnitudes. But when measuring physical quantities, we defined a common unit system. We should define a common unit system. Now, earlier days, right? To measure the physical quantity, let's say, for example, length. To measure the length, actually they used to measure the length of something. Length of a house, length of some kind of object. To measure the length, they were using some ancient units. They were called, we can tell, inch, if not feet. We all know feet, that is one of the popular units to measure the length, feet. Right? And ancient times they used a unit called A unit called Q, what's that? It's cuboid, no? Earlier days, they used a unit called, right, okay, they used a unit called, I think it's cuboid, okay, right, okay, give me 1 second, okay, right, okay. So likewise, feet, earlier they used feet. If not, we can tell that cuboid, there's another unit, right? To measure the mass, they used seeds and grains. Seeds and grains. Seeds and grains. There were some problems, right? And then to measure the time, especially, they used some right sundials, and there are some water. There are some water setups also. Sundials, right? Okay, no? Right. Now, what is the problem? Now, earlier to measure the length, they used feet. What is the main problem? For a country, let's say now they considered the king's feet, the king's feet as the standard unit to measure the length. But what is the problem? What is the problem then? When the king dies, then when the new kings comes to rule the country, because we know that different people are in different shape, their lengths, their feet size and all different. Right? When they are using the feet as the unit, then what happened was different human bodies can have different sizes of feet. And in some countries they use that distance from this here to here, mid of the finger to this elbow. They used as a unit. Different people have different sizes. As a result, what happens? There was a conflict between the people. The people know what to consider. To measure the length of something, do you want to consider this one's feet or do you want to consider that one's feet? When the king, even the king, then they came with the standard feet size as king's feet. In that case also there was a problem when the king changes. When one king dies and another one is coming to the rule, the problem is then also there's a problem. Then there are lots of problem. Even if you're using some units, especially like feet, they struggled because it is not common, it is not unique everywhere. People to people, feet size different, right? Therefore, there's a problem with measuring the length also. And especially mass, to measure any unknown mass. To measure any unknown mass, they use some known seats. Based on number of seats only, they measure the mass. For example, let's say now you have a kind of, an object. So then you don't know this mass of the object. So what you do in the balance tray, one side you are placing this unknown mass and other side you are placing another tray. In the tray you are inserting seats. Based on the number of seats which tally the weight, only you are telling this one's weight is, for example, 125 seats. That's how they used to measure the mass. And especially time. When measuring time, you all know that based on our sun's motion from east to west, that story, based on that, there's a kind of instrument they developed. It's what we call a sundial. Based on the shadow of that stick projected into that plate, based on the shadow only, they found the time. But there are problems because especially the sundial, to measure the time using sundial, if it is a cloudy day, they can't measure the time. And also, we know sun disappears at night time. So there were no way to find the time at night times because they can measure the time somewhat accurately using sundials. So the problem is if it is cloudy day, they can't measure the time. The next story is at the night times, they can't see the sun. No? So therefore, they can't measure the time. There were lots of problems. There were lots of problems when trading. When trading also. When trading between different people in different country. Right? Because different people, different country, they have different systems. So therefore, this made a conflict between people and finally, people agreed to come to a common unit system. That is the whole summary. Finally, people agreed to come to a common unit system. That is what we are going to talk right now. Okay, very simple. We all know that very simple. First story, very simple. We talked about physical quantity. Then any quality or quantity, any difference in the universe, if we can measure it, then we call it physical quantity. We know the examples. Then we want to measure the physical quantity. All the physical quantities have some kind of magnitude. But when representing the magnitude, we require unit system. Then ancient time, the people used different unit systems to measure the magnitudes of different units. Then they faced lots of struggle. As a result, what they have done, they all agreed and came up with one unit system. But still, that commonly agreed system is changing day by day. Currently, we are using SI unit system. That's what we are talking in a while. This is the overall idea. And just put small reply, respond if all okay. This history, not a big deal. This history is very clear, all okay. Give me a small thumb. This idea is okay. If all good. If this idea is okay, if all good, give me a small response. Give me a small response. Give me a small response. Put better if you can put some thumbs, and if you can respond, it's really better. It's really better. Right now? If all good, you can put a small response also. All good, no? Right, okay. Then go to the tutor and we'll write the next note. Go to the tutor and we'll write the next note. Go to the tutor. And next idea. Right? Okay. Then next idea. Okay. Right. Okay. Then we wrote page number 1, requirement of units, no? In the example, write down. In the given space, example, write down. In the given space, example, write down. If you say length of a table is 5, write down there in the given space and example. Write down. If you say the length of a table is 5, comma. If you say the length of a table is 5, comma, it doesn't make sense. It doesn't make sense. It doesn't make sense. Full stop. But if you say 5 meter, 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 comma, the quantity is clear, comma, the quantity is clear, comma, the quantity is clear. Full stop. Here, 5 is the magnitude and meter is the unit. Here, 5 is the magnitude and meter is the unit. Here, 5 is the magnitude and meter is the unit. Okay. Then all measurements include following properties. There are 3 properties you want to understand. Right, number 1, write down. Number 1. Now, any property have following, any measurement have following properties. Number 1, write down. Numerical value. Inside the bracket, magnitude. Any measurement, it has a magnitude, no? Number 1, write down. Numerical value. Inside the bracket, magnitude, close the bracket. Number 1, magnitude. Number 1, numerical value. Inside the bracket, magnitude, close the bracket. Right? Next idea. Number 2, write down. Number 2, unit. Number 2, unit. Number 1, magnitude. Number 2, unit. Number 3, nature of the quantity. Number 3, nature of the quantity. Inside the bracket, write down vector or scalar. Vector or scalar. Vector or scalar. Right? Okay. Now, any measurement. There are 3 main properties. One is the magnitude. That is clear. Number two is unit. That is also clear. Third idea is, we all know third idea, any measurement, the nature of the quantity. That means whether it's a vector or scalar. That physical quantity, that measurement is a vector or scalar. Then what is vector and what is scalar? What is vector and what is scalar? There are some physical quantities. To describe the physical quantity, only magnitude is sufficient. For example, the mass is a scalar. Mass is scalar. Why? Because to describe the mass, to express the mass, only the magnitude is sufficient. For example, you can ask from someone, please bring 5 kilogram of sugar. Please bring, 5 is the magnitude, kilogram going to be the unit. Please bring 5 kilogram of sugar means anyone can understand the physical quantity, that mass properly, that measurement. But for an example, when you consider force, we categorize force as a vector. Mass is a scalar, force as a vector. The reason is, to describe the force, only mentioning the magnitude is not sufficient. For example, if you say that now you all know, all levels you learned, what is the units that we use to measure the force, newtons. If you tell that apply 10 Newton force on this object, you have problem, sir. Now, okay, you are telling to apply 10 Newton force on the object, so what direction? You want me to apply the force on the object vertically downwards, so vertically upwards, so to the right side direction on the object, to the left side direction on the object. You are not very clear, no? So therefore, there are some physical quantities only describing the magnitude is not sufficient. We should define the direction also. And then what is a vector? What is a vector? Physical quantity which requires magnitude and direction to describe the physical quantity, they are vectors. What is a scalar then? Any physical quantity only magnitude is sufficient to describe the physical quantity, that is going to be scalar. We will learn these vector scalar stories in vectors lesson under mechanics. We are talking vectors and scalars idea more deeply in vectors lesson in it too. But I'll give a small idea. Right? Vectors and scalars. Next idea. The next idea, physical quantity. Remember, physical quantities, again we can categorize into two categories. Based on the nature, physical quantities so we can divide it into two categories. One is a scalars. The second category is vectors. Scalars. Second category, vectors. Then what is the important point? How to differentiate a vector and scalar? Physical quantity which only requires a physical quantity which only has a magnitude. Physical quantity which only has a magnitude, they are scalars. Magnitude. What is the vector? Vector means physical quantities which have both magnitude and direction. Right? Vectors, they have both magnitude and direction. Both magnitude and then direction. Okay? Then you can tell some examples for scalars and vectors. Roughly remember, mass, volume, 1 liter of milk. Right? Mass, volume, now area, 5 meters squared area. Distance, they all are scalars. For example, you can write down mass and volume, distance, they all come under scalars, right? Then give me example for vectors. Put some replies, respond you all. Give some examples of vectors other than, okay, force is a vector. We all know that, as I explained already, to describe a force properly, only magnitude is not sufficient. We require a direction also. So therefore, you all agree, force is a vector. Tell me, other than force, give some other examples for vectors. 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 Other examples for some vectors. Give some other examples for vectors. Vectors. Any idea? Any idea? Any idea? Anyone? Give some examples. Give some examples for vectors. Now weight is, yeah, obviously displacement, very good. Now people are saying, you all are saying acceleration is a vector, nice story, nice. Velocity is a vector, weight is a vector, deceleration is also acceleration, very good, very good. Velocity, acceleration, displacement, what else? Very good, okay. Velocity, very good, velocity, acceleration, displacement, they all are vectors, right? Displacement. Then better please write the story also somewhere else. Then we understood. In summary. Always, even though we talk so many stories, at the end the summary that you want to put in your mind is very small summary. Now we were talk now today we start the class at 7 o'clock and our time is almost going to 8 o'clock. Right? In the beginning we have to talk some stories, therefore I'm spending some time, but remember today only we are talking this level and we are studying something, right? But it's a basic theories, no? Now just go from the beginning, then we start physical quantity, then we know what is a physical quantity, right? Then any changes happening in the surrounding, if you can measure it directly or indirectly. Then what are the changes? What do you mean by the changes? Then we identified plenty of changes, plenty of physical quantities. Then what do you mean by directly measuring, indirectly measuring? Qualitative, quantitative ideas. That story. Then we talked about some history of importance of unit, no? Importance of a unit, we talked the idea. Then we came to the nature of a physical quantity, vector, scalar, that idea also clear. Right? That idea also clear. And now I think we can, step by step, we can go to the next stories. Right. Now what you do? Right now what you do? Take your Tewton. Take your Tewton. Now time is not a vector. We all know time is a scalar. Time is a scalar. Right? Moment, it's a vector. Very good. Then we wrote that all measurements include following properties. Any measurement has a magnitude, then unit, then its nature, whether vector or scalar. That idea also clear. Then write down in the Tewton, page number 1, external properties of standard units. External properties of standard units. This is not that much important, but number 1 write down. Availability slash accessibility. Availability slash accessibility. Don't worry, I will explain. Number 2 write down. Number 2, invariability. Invariability. This is not that much important, but better to write and better to write as a note. Number 3 write down. Reproducibility. Number 3 write down. Reproducibility. Right? Last one write down durability. These are 4 external parameters, 4 external properties of a standard unit. Okay? Right, okay. So then I explained that earlier why they used different unit systems and why do we want to agree for a common unit system. We talked briefly the idea, we explained. That idea also clear, right? Then different time periods, the entire world agreed to use a common unit system, but time to time that common unit system they used were different. Time to time they used different common unit systems. First of all, now page number 2 write down. Different countries around the world use different units to measure physical quantities at different times, right? Number 1 write down. Number one, write down capital F dot, capital P dot, capital S. I will explain. Capital F dot, capital P dot, capital S. Many countries, including England, use feet, pounds, seconds. Capital F is feet, capital P means pounds, capital S means seconds. Then the second given space write down, the second given space write down, second given space write down, the second given space write down. Capital C, capital G, capital S. Capital C, capital G, capital S. Centimeters, grams and seconds. I will explain, don't worry. Centimeters, grams and seconds. Capital C, capital G, capital S, centimeters, grams and seconds. Third space, right on the third space. Capital M dot, capital K dot, capital S. Capital M dot, capital K dot, capital S. Capital M dot, capital K dot, capital S. Meters, kilogram, seconds. Meters, kilogram, seconds. Right. Okay. This story. Look here. Okay. Right. Okay. Right, okay. Okay. So then ancient times they used a different set of units to measure the physical quantities. Then different times they used different systems, FPS, then CGS means centimeter, grams, seconds, then they went to MKs, meters, kilogram, second stories. Now then finally they all agreed to use a SI, Standard International Unit System. That is our lesson. This is our lesson. Actually lesson is starting from here onwards, therefore stay focused and we'll learn. Okay, time is almost 8 o'clock. Today class we are doing till maximum 9:30 maximum, right? Then SI system. Okay, go to the page number. Go to the page number. Okay. Go to the page number. Okay. In the tute, go to the page number. In the tute, go to the page number. The tute, go to the page number. The need of an international unit system. The use of different, page number 2. The use of different unit system for measurement in different countries is an obstacle to the advancement of science as well as human civilization. There are two main disadvantages of using different units in the different countries. Difficulties in various scientific work that scientists around the world do together and exchange ideas about new discoveries can understand. Next point is inconvenience in international trade. For these reasons, it was decided everyone in the world should use the same unit system in scientific work, and 1960 the international unit system was introduced. The history, right? Okay. Now go to the page number 3. Page number 3, and now SI, International System of Units, SI. This is our today lesson. Now every point matters, stay focused and learn. International System of Units. International System of Units, SI. International System of Units. Units. SI. Right. Now units used under International Unitary System can be divided into 5 main categories. Write down below. Number 1 is write down base units, if not basic units, fundamental. There are different words. Write down number 1 basic units. Number 1, basic units. Number 1, write down basic units. Number 2, write down supplementary. Number 2, supplementary units. Number 1, basic units. Number 2, supplementary units. Number 2, supplementary units. Supplementary units, number 2. Third one, write down third one. Third one is derived units. Third one, derived, D-E-R-I-V-E-D, derived units. Derived units. And then fourth one, write down multiple units. Fourth one, multiple units. Fourth one, multiple units. And fifth one, write down additional units. Right. Fifth one, additional units. Okay. Right. Okay. 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 Right. Okay. Now first we'll talk about base units. Now hereafter, keep your focus and learn. Every point matters. Keep your focus and learn. Right, base units. Right, base units, if not basic, if not fundamental. Remember, there are 7 basic units. You must remember. There are 7 basic physical quantities, and for those 7 basic physical quantities, there are 7 basic units. Okay, basic. If not, we call base. If not basic, if not, we can call it as fundamental quantities, fundamental units. Fundamental units, fundamental quantities. Right? Fundamental units. Base, basic, fundamental. Fundamental. There are 7. You must remember these 7 physical quantities. You must remember. You must remember. Right? There are 7 basic physical quantities and 7 basic units. There are 7. Now in the given table, write down number 1, write down first one, write down. First one, write down the given table. First one, we all know that now. If I ask you how many physical quantities are there in use and how many physical quantities we can define, remember there are plenty of physical quantities like mass, length, time. Likewise, there are plenty of physical quantities, and if you obtain the importance of those physical quantities, so we can bring 7 main physical quantities as our basic quantities. Then definitely we all know that mass should be one of the basic physical quantity. Definitely length must be one of the basic physical quantity, and time is also should be one of the basic physical quantity. Therefore, write down number 1. Write down number 1, mass. Number 1, write down mass. Number 1, write down mass. Number 1, mass. Okay. Number 2, write down. First of all, we'll complete the basic quantities, and then we'll talk about their SI units and symbols. Number 1, mass. Number 2, write down. Number 2, write down. Length. Number 3, time. Mass, length. Number 3, time. Right? Number 1, mass. Number 2, length. Number 3, time. Mass. Number 2, length. The third basic physical quantity. Basic quantity is time. Now, anyone can understand why these 3 should be basic physical quantity because of their use. Addition to these 3, there are another 4 basic physical quantities. Write down next 4. Any guesses? Any guesses? What are the next four basic physical quantities? Any guesses? Can someone tell me? What should be the other basic physical quantities? What should be the other basic physical quantities? Anyone? Mass, length, time, and what else? Mass, length, time. What are the other possible physical quantities which should fall under basic quantities? Then we all know that this electric current, then temperature, current, electric current. Then temperature, number 5, temperature. Right? Then number 6, luminous intensity. Number 6, luminous intensity. Number 6, luminous intensity. Luminous intensity. Number 7, remember, that is the amount of matter. Amount of matter. Amount of matter. Amount of matter. Okay. So then these are the 7 basic physical quantities. You must remember: mass, length, time, current, electricity, temperature, luminous intensity, and the last one is amount of matter. You must remember these 7 basic physical quantities. And if you go to their units, and the units, right? Units. Then mass is measured in, we know the SI unit to measure the mass is not grams. Sometimes we think like SI unit to measure the mass is grams. That's wrong. It's kilograms. It's kilogram. The symbol is, symbol of the unit is, remember, that is, remember, simple K, not capital K, simple K, simple G. Especially the symbols in units, they are really case sensitive. So therefore, don't write capital K, simple G. If you write capital K, simple G, they don't give marks. So therefore, the symbols of mass must be simple K, simple G. Simple kg. Length is measured in meters. Meters. The symbol is simple limb. Meter, simple limb. And time is measured in seconds. SI unit to measure the time is seconds. Second. Symbol is not capital is, simple is. It is measured in seconds, simple is. And electric current, you might learn in all levels. The units used to measure the electric current is amperes. Symbol is capital E. Ampere. Symbol is capital E. Ampere. Temperature, remember, that is measured in Kelvin, not Celsius, not Fahrenheit. Temperature SI unit is Kelvin. Symbol is capital K. Symbol is capital K. And luminous intensity, I think you all familiar with mass, length, time, electric current, and temperature. And also you might have an idea about this amount of matter also. But the problem is you may have problems of what do you mean by luminous intensity. This link with the light section, some stories. Okay, right. If I explain right now, okay, then mostly if I try to explain what is luminous intensity right now, sometimes I don't know how many of you will understand. So therefore, we'll see. Luminous intensity, remember that link with some light intensity, the light electromagnetic waves, and it linked with intensity stories. We will learn in unitary oscillation and waves. We talk about intensity, sound intensity. We talk there. But this idea, I will give an idea. I'll give an idea. Don't worry. Definitely, I will give an idea about luminous intensity, but not now. Okay, I'll give an idea. Don't worry. Then luminous intensity is measured in candela. 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 A candela. Symbol is simple C, simple D. Simple C, simple D, candela. Amount of matter is measured in moles. Right, moles, simple M-O-L, mole. Moles. M-O-L, simple M, simple O, simple L, moles. There are 7 basic, if not fundamental, base physical quantities and base units. Then remember mass means kilograms, length meters, time is seconds, electric current is ampere, temperature is measured in kelvins, luminous intensity measured in candela, amount of matter measured in moles. This is the idea. This idea, all good answer. This idea all clear and all good. Give some response, all good, all clear. This idea very simple answer. This idea is clear, this idea is simple. Give a small response. This idea is clear, this idea is simple, understood. Please put in your tutor, in the tutor, write down the stories. Give a small response, all good, all clear. Give me a small response, you can put a small thumb and you can tell me. So all good, all clear, idea is clear. Idea is clear. Very clear, very clear. Now don't worry. One thing I will tell you now, listen. Now last week we just gave a small introduction about the lesson, but we didn't do any class last week. Just today only we have started the lesson. Don't worry about this lesson, okay? Don't worry about the lesson, right? I am teaching A to Z, so you don't need to worry. From the basic level to the pro level, I am teaching every story in our classes. Since you are very new, sometimes you don't know what's really happening in our classes, right? Our class is 100% perfect class. In theory explanation wise also, and number of questions we discuss in the class, not only the tutored questions, but also we are doing past papers for 27 batch. Currently we are doing, now we promised to do 1990 to 2027 A-level past paper questions for 2027 batch, right? I told them we are doing around 35 years of past papers, not selecting few questions and not doing like that. We are doing complete papers, and parallelly we are doing our model paper class. So this class is fully English, right? We can talk in Sinhala, right? We can talk in Tamil, right? Actually I'm expert in both Sinhala as well as Tamil. But since our motive is we want to provide a quality English medium physics class, even I know Sinhala, even I know Tamil, usually I don't use them, right? Because when I start using Sinhala, Tamil language, and if I start teaching, this is not going to be an English medium class, right? Right? There are classes, they are using Sinhala and sometimes Tamil, and they are teaching English medium classes. It's not recommended. Because since you are doing A-level English medium, you should learn everything must go into your mind in English, right? If what will happen that if you learn in Sinhala or Tamil, now you are doing A-level English medium, and if you are learning via Sinhala or Tamil languages, what will happen? There's a transition, right? You get the data in Sinhala or Tamil and you want to transfer it to English and you want to put in your mind, because you are doing English medium, right? So then it takes some time to process the data properly and to get the idea. And genuinely it makes you slow. Therefore, normally I don't use Tamil or Sinhala in the classes. We are doing fully English medium, English class only, English medium. We are talking only via the English, that story, right? And also now you will understand. Now we started today, and we are doing some sections today. Now these are very basic sections. since we want to do a kind of big introduction for that story, I talked some stories regarding units and dimension stories. But upcoming days, you will understand we are doing huge number of questions. We have a very huge work plan, right? So I will tell that if you really want to get A, only come to the classes. Otherwise, no point of joining a class. If you want to get a pass, then you can go anywhere, right? If you want to get a pass as result, you can go anywhere, right? Everyone doing classes nowadays, no? Therefore, if you really want to get A result, right, we are working only unconditionally. We are working unconditionally by putting our 100% commitment. We are working, right? Students who are coming to my classes, they know that let's work together. We'll go for a not just a result. We'll break the result and we'll go for the maximum. We'll go to the maximum result. If you are planning to get A, try to get A plus. That level we are teaching. So from the bottom to top level, we are teaching every point properly, right? Therefore, you don't want to keep any doubt regarding that story. Okay. So then this side is clear. This idea clear. This idea is clear, right? Nice story. Okay, done. Next story is supplementary units. You don't know supplementary units means there are 2 supplementary units in your syllabus. There are 7 basic units, and if I explain supplementary units, supplementary, very important story. Supplementary units, supplementary. Okay, supplementary units. Supplementary units. Okay. So when you talk about supplementary units, write down there are 2 supplementary units. Number 1 is write down plane angle. Number 2 is write down solid angle. Number 1 is plane angle. And I forgot to tell one story now. Most of you coming from sometimes physics subject, we need lots of math simplifications. But some of you might have forgotten some basic maths like triangle, isosceles, equilateral triangle stories, then sine, cos, tan ideas, trigonometric ratios, and then log simplifications, then indices, fractional formats. If you are not very unfamiliar, or if you forget those stories, don't worry. As a separate session, we are doing on Friday. On Friday, we are doing from 7 to 8 p.m. Right, revising some maths parts, which is important to do some physics questions, calculations. No need to separately teach that idea, but we are assuming at least there are some people who need that, who require that session. For them, we are doing that session mostly Friday. We are starting from Friday, not today, Friday. So you can join for those classes and you can get the benefit. Then maths part is also covering in those classes, and right, everything we are doing very smoothly. And also people who requested the tudes, we posted the tudes. Mostly you will get the tude in a week, right? If others can manage the tudes, that's okay. Generally every month, the first week we are providing the tudes. But since we are doing the classes this month free of charge, anyone can join for the classes. I didn't post any tudes, but I shared the PDF version of the tudes in the groups, and people who requested printed tudes, I posted tudes for them only, right? If you can manage the PDF, then it's okay. But if you require a printed tudes, then put a WhatsApp message, then I will tell you the procedure. But April onwards, you are getting printed tudes directly posted to your home. Therefore, no need to worry about the tudes, all the past papers, and you don't want to buy any resource book also so far, because I am providing all the study materials. I am providing the tudes and question tude. I'll provide the past paper tude, all the model papers I'm posting. So therefore, so far right now, you don't need to buy any additional books. I will tell you. After some months later, I will tell you which books you want to buy for your additional knowledge. That's what I will tell you. Okay? Right. That idea okay? Then right, quantity. Then we talked about units, quantity, units, and next idea is symbol. Symbol. There are 2 supplementary units in your syllabus. Number 1 is, remember, plane angle. Number 1 is plane angle. Number 1 is plane angle. Plane angle. We all know angle. So what is plane angle? We learned angle. What is plane angle? Plane angle is exactly same what you learned in all levels. Angle is what you call as plane angle. But I will do the definition in different way in a while. Other number 2, second supplementary is solid angle. Solid angle. Solid angle. What is the SI unit to measure the plane angle? Radian. 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 What is the symbol for the SI unit radian? Rad. Simple R, simple A, simple D, rat. Simple R, simple A, simple D, rat. That is okay. Then sir, solid angle SI unit is steradian. 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 Symbol is SR. Symbol is SR. SR. S simple is simple R. Then you have problems now, right? I understood. I didn't understand what is luminous intensity, physical quantity. Remaining all okay. I learned in all levels. And sir, now you talked about two supplementary units also. I understood what you explained, but I still didn't get the idea. What is a plane angle and what is solid angle? Right, this is not mandatory, but I will give a small idea. Remember, plane angle means if you consider an arc, sorry, circle. In a circle, let's consider an arc. Plane angle idea, okay? Just roughly remember, but this is not that much important, but roughly remember what is a plane angle. Right, the idea is when you consider circle of radius simple r, of radius simple r, a circle of radius simple r. And when you select an arc length, let's say arc length is capital S. If you select an arc length, the circumference arc length, this is going to be the arc length, right? This is the arc length. Arc length. Now you can select any arc length having any length. When you select an arc length from a circle, the angle subtended by the arc length, angle subtended by the arc length at the center. The angle subtended by the arc length at the center, that angle is what we call as plane angle. Do you understand? Right? Angle subtended by the arc length at the center is we call as plane angle. Right? This angle is what we call as plane angle. Plane angle. Plane angle. Right? Very simple. What is plane angle? When you consider circle of radius simple r, if you consider circle of radius simple r, and when you select an arc length of capital S, if you select an arc length of capital S, angle subtended by capital S arc length at the center is we are calling as the plane angle. Now, solid angle is somewhat difficult to understand. Solid angle is somewhat difficult to understand, but you don't want to know. But I'm just giving an idea. I roughly give an idea. Solid angle means, remember, angle subtended by an area on the surface of a sphere of radius simple r at the center. Once again, if I repeat, what is solid angle? Solid angle means, remember, angle subtended by a area on the surface of the sphere. When you select an area on the surface of the sphere, area subtended by that surface at the center of the sphere is solid angle. If I say like that, you don't understand. I draw a diagram, I will show you. I draw a diagram and I will show you the idea. If I draw a diagram for your understanding, solid angle diagrams. If I draw a diagram, solid angle diagram, look here. Solid angle diagram, right? If I draw a diagram, just try to get this idea. When you consider sphere, now I can't draw a sphere properly, no? In a 3D manner, we can't draw. In this 2D whiteboard, I can't draw any 3D objects. Then you want to imagine. If I draw a circle, you want to understand that is a sphere. And you want to think 3D manner. Okay? Now I can't draw a 3D sphere in the whiteboard, right? Therefore, I am this time now here I draw a circle. This time I am representing a sphere by drawing a circle. Imagine properly. A solid angle means, remember, solid angle idea. Solid angle idea. If I draw a sphere of radius simple r, sphere of radius simple r, and select capital S area on the surface of the sphere. On the surface of the sphere. Now, what is surface area of sphere, right? The area that you can touch on the surface of the sphere, surface area. If you select capital S surface area on the sphere, when you select capital S surface area on the sphere, capital S surface area on the sphere, the angles obtained by capital S surface area at the center of the sphere. The angles obtained by capital S surface area at the center of the sphere is what we call as solid angle, right? This is what we call a solid angle. Okay, this area. So this angle is what we call a solid angle. Remember, plane angle is a different story. All levels in your geometry, the angles are plane angles. But solid angle idea you never learned in O levels also. We are not learning in A levels also. But just you want to remember there are two supplementary units. One is plane angle, the other is solid angle. Remember there are units, steradian, radian, that idea. But roughly remember, solid angle means when you consider capital S area on the surface of a sphere, the angle obtained by that surface at the center is the solid angle. Right? It's not a 2D angle, it's 3D angle, solid angle. Solid angle. This idea. For an additional knowledge, you can write stories. Then we talked about basic and supplementary units, right? That idea done. That idea done. Time is 8:22. We can okay. We'll do the class. Okay, we can take a small break in a while. We'll do next story also. Next story also. Go to the tute. In the tute, we'll take a break in a while. We'll take a break in a while. Next story. The next idea. Then we talked about basic, supplementary, derived units. What is derived units? What is derived units? Now, even though we define 7 basic units and 2 supplementary units, we all know that there are a huge number of other physical quantities. Right? Most of the physical quantities are formed based on basic physical quantities. That means there are other physical quantities, they are formed, they are defined based on the basic physical quantities, 1 or 2 or 3 or 4 basic physical quantities. For example, I'm telling, let's consider area. For example, area. Now area. Okay, if you consider area, what is the equation or definition you can remember about area? Length into breadth is an area. Length into breadth is an area. Area means what? We all know this equation. Area is a physical quantity. The definition, if not the equation, is length into breadth. Length into breadth is area. Right, okay. That means now area is defined as length into breadth. Length, that is one of the base quantity, one of the basic quantity, length, yeah. Breadth is also a length, no. Height, distance, circumference, they all are lengths. Breadth, width. Then length is a length, basic quantity. Breadth is also a length, basic quantity. That means this physical quantity, area, is defined using basic quantities. Then that means this is a derived physical quantity. If we can derive, if we can introduce, if we can define physical quantities using the basic quantities, then they all are come under derived quantities. The volume. Volume is what? Length into width into height. Length into width is also length, height is also length, length into length. Then lengths are basic quantities name. Therefore, volume is also a derived physical quantity. Let's take another one. Give me some example. You guys tell me some examples. What are the other physical quantities you know? Give some replies. What are the other physical quantities that you know? I will tell you how it is considered as derived quantity. I will tell you. Give some other examples for other physical quantities. Give some examples. Like area, like volume. Give some other examples for physical quantities. Give some other examples for physical quantities. Give some other examples. Give some other examples for physical quantities. Other examples. Give. Your idea. Momentum. Okay, momentum. Right, momentum is a good physical quantity, but anything simple, yeah, momentum is also derived physical quantity. I will derive that in a while. Any other easy quantities that you know other than these things? Density. Density. Okay, density is a nice example. Density. Okay, density. I'm raising this seven, but you must remember. Okay, you must remember these seven quantities, right? Okay, density. Now, density means all levels fail in the equation. Density means mass or volume. Density means we all know, sir, that is mass or volume according to the definition. Density, that is equal to what? Mass over volume. So now mass is a basic quantity, no doubt. Mass is a basic quantity. Basic. Just now we learned volume physical quantity also derived from basic quantities. Volume means length into width into height. So this volume is also derived from a basic physical quantities. Then sir, density must be a derived physical quantity from the basic quantities. Clearly, you can write down if you want. You can write down like this. You can write down density as mass over volume means what? Length into width into height. Length into width into height. Length into width into height. Length into breadth into height, whatever. Then basic. Width and heights are lengths, no? All of these are basic physical quantities. Basic physical quantities. They all are basic. They all are basic physical quantities. Clear? Right, okay. Now I have an idea about what is derived physical quantities also. Take your tutor and write down. We'll take a break in a while. Time is 8:30. Okay, time is 8:30. We were doing the class for 1/2 an hour continuously. We'll take a small break. We'll take a small break. Give some respond. We'll take a small break. Put some respond. We'll take a small break. Now weight, force, pressure. I can derive. We are deriving today. Okay, don't worry. We'll take a small break and we'll come. Just put some respond. If it is Zoom is, you to be somewhat different, right? We'll take a small break. Okay, time is now 8:30. Today we are in the class maximum 9:30, maximum 9:15. We can stop also, right? I think we started with a proper starting. No? So what shall we do? We'll take a small break. Time is 8:30. Take maximum 8:45. Take maximum 15 minutes. Maximum 15 minutes. Come at 8:45. Then we are doing till 9:30. Take a break and come. Take a break and come. Right, okay. So then we'll start again. I think we talked about basic quantities and basic units. Then we talked about supplementary quantities and supplementary units also. Then we realized, we knew that what is derived quantities. If a physical quantity is derived from basic physical quantities, if the physical quantity is defined from basic physical quantities, that is going to be derived physical quantity. And now we'll talk about derived physical quantities. Okay, listen very carefully. Derived physical quantities, based on the structure, we can divide derived physical quantities into three different categories. We can divide derived physical quantities into three different categories for our easiness. Derived quantities, physical quantities. Now, the first category is derived physical quantities with the compound names. Compound names. Derived physical quantities with compound names. The second category of derived physical quantity is derived physical quantities with special names. You'll understand. Compound names. The second category is derived physical quantities with special names. Special names. The third category is a mixture of these two, derived physical quantities of compound special names. Special names. The third category going to be compound special names. Compound special names. Compound special names. The mixture of these two, compound special names. Right? Okay. First of all, we'll talk derived physical quantities comes under compound names. Go to the tute and go to the page number in the tute. In the tute, go to the page number. In the tute, go to the page number. Go to the page number in the tute. Page number, I think we talked about page number 1, 2 done, page number 3 also done, page number 4. In the tute, page number 4, write down in the first given space. Under derived units, in the first given space, write down units which can be obtained using basic units. Right there, units which can be obtained using basic units. Units which can be obtained using basic units are called derived SI units. Are called derived SI units. Are called derived SI units. The second point I gave, I have given SI unit of a derived physical quantity can be obtained by using the definition of the physical quantity. That means the equation. You will understand in a while. The next given space, write down next given space. In writing the units, there should be a gap between. In writing the units, there should be a gap between the symbols of basic units. The symbols of basic units. In writing the units, there should be a gap between the symbols of basic units. Please highlight the entire sentence. Highlight the entire sentence. And now we'll talk about derived units with compound names. Okay. Then I have given a table, right? Quantity, definition, and SI unit. You guys can derive it. Start the derivation. Obtain the SI units of those given physical quantities. Go to the page number. The given page number 4, area, volume, velocity. quantity. Now I'm talking derived physical quantities with compound names. Okay. Right. Then quantity. Quantity that is number one is area. Number one is area. What is the definition of the area? Definition of the area is, we all know that length into breadth. Write down quantity definition. Write down here, how do you define the area? What is the equation for the area? Length into the width. Length into the breadth. Length into breadth. Then tell me, what must be the SI units of area? So length is measured in meters. Length is a basic quantity. It is measured in meters. Breadth is also a length, no. Therefore, breadth is also a basic quantity. It is measured in meters. Meters into meters. Meters into meters means, remember, the SI unit going to be meter squared. Meter into meter means, remember, meter into meter, meter squared. Number two, volume. Likewise, find the SI units of these derived physical quantities. Number two, volume. Then volume, we all know that volume means, the definition is length into breadth into height. The definition, write down. Length into breadth into the height. Length into breadth into height. Height, it's height. Then basic unit, length is a basic quantity, breadth and heights also basic quantities. Therefore, they are measured in meters into meters into meters, meter cube. Meter cube. Number three, volume. Number three, velocity. Velocity means, you can remember the definition, all levels you learn. Velocity means, we all know, displacement over time. Velocity displacement, write down, displacement over time. Displacement in the given box, write down displacement over time. Displacement over time is the definition. Now some of you might forgot the displacement is also a length. We will learn in mechanics, we will learn, remember, displacement is also a length. Remember, displacement is also a length, right? Displacement is also a length. Therefore, what is the units of displacement? Meter, right? Units of displacement is meter. Then time is a basic quantity. What is the units of time? Seconds. Displacement is meter over units of time is seconds, right? When the second goes to the numerator, right? Just think when the second is at the denominator. What is the power of a second? 1, no? The second is at the denominator, the power of s is 1. When the second goes to the numerator, it becomes s to the power minus 1. Therefore, you are getting meters per second, right? That idea. Then m is minus 1. M is minus 1. I told you to highlight a point, no? I told you to highlight a point. I told you that, if you can remember, I told you a point. In writing the units, there should be a gap between the symbols of basic units. Now we know that meters is a basic unit. Second is also a basic unit. When you're writing meters per second, please don't write down. Please don't write down very close meter and second. Don't write very close. It's wrong. They are really checking properly, okay, in your exams. When writing these meter and seconds, two basic units, there must be a kind of small gap. In order to maintain the gap, you don't draw 1 meter is like here and don't write second is like this. Just keep a considerable small gap between meter and second. Is the idea. Then number 4. Acceleration. Acceleration, remember the definition is velocity over time. We will learn. In upcoming mechanics sections also we'll learn these ideas, don't worry. Acceleration, write down, that is, remember, acceleration is, remember, that is velocity over time. Acceleration, that is, remember, that is velocity over time. Velocity, you keep on doing the stories. Velocity over time. Velocity essentially is just now I found essence of velocity is meters per second. Meters per second over units of time is seconds now. Now again, this second is at the denominator, the power of the second is 1. When the second at the denominator goes to the numerator, it becomes s to the power minus 1. Already m s to the power minus 1 is the numerator. When s to the power 1 also goes to the numerator, it becomes again s to the power minus 1. All levels you learned s to the power minus 1 into s to the power minus 1. You can add these powers minus 1 plus minus 1. Minus 1 plus minus 1 going to be, remember, minus 2. Minus 2. And then we can write down m s to the power minus 2. In our basic that maths foundation, I will teach the stories also, don't worry. M s to the power minus 2. Right? Likewise, density, then momentum. Density, momentum. Density, number 5, density. Definition is mass over volume. Density means we can remember mass over volume. Mass over volume. Mass over volume. Mass, SI units of mass is kilogram. But I told you, don't write down simple K, simple G. Don't write capital K, capital G. Kilograms over, what is the units of volume? It is meter cube. SI units of volume is meter cube. Meter cube. M to the power 3. When the m to the power 3 is currently the denominator, if it goes to the numerator, it becomes m to the power minus 3. Then kg, m to the power minus 3. Okay? Then the SI units of density going to be kg. A small gap between kg and simple m, ensure that story. M to the power minus 3. Last one is momentum. Sometimes you might forget in all levels you learned momentum, right? Can someone tell me what is momentum? Let's put a respond in the chat. Can you tell me the equation for momentum? Anyone can tell the equation for momentum? Give me a small response. Anyone can tell me the equation for the momentum? Anyone? What is the equation you learned for momentum? Just reply, okay? Now I also agree better if we can go for a YouTube, go for a Zoom session than YouTube. But only tolerate for this class and another one class, then we are going through the Zoom classes, don't worry. Anyone can tell what is the equation you learned for momentum? Very good, mass into velocity, very good. Mass into velocity. Momentum means mass into velocity. In mechanics, we are learning momentum as a separate lesson. It's a big lesson. We talk about conservation of linear momentum there, and we talk about conservation of energy there. So we are doing questions combined with conservation of linear momentum and conservation of energy. It's a nice story, but very good. Most of you can remember. We can remember, yes, mass into velocity. Good, but superb. No, write down the last one. Last idea. Then now interesting to do something, right? We just started today. No, don't need to go in a hurry. We'll study everything properly, but every moment that you are spending, please put a value for the time. Interestingly study. Okay? Just because your parents are telling you, just because want to study, don't study. Right? When you are spending your time, please 100% efficiently spend the time. Because when we are watching a movie, right, how interestingly we watch the movie. Sometimes we don't even look our eyes out from the movie, right? Even your mother is calling, father is calling, even the mother is scolding you also. Sometimes we don't turn our eyes also away from the movie, because even if we miss a small part in the movie, sometimes we don't understand the climax. If you can give a priority to watch a movie, if you can give a that level priority to watch a movie, now this A-level journey, it's your life, right? It's your life. Then why don't you putting your 100% commitment, and why don't you ready to work unconditionally, therefore nicely? Okay, when you are doing a session, don't spend any single second waste, right? Every second effectively spent. Get a maximum benefit from the time that you spend. That is the important thing. Right, the mass and velocity, very good. Next story, momentum. We are calling it as linear momentum. Linear momentum only, but it's okay. Momentum, remember the equation is momentum. You will learn, don't worry. If you can't remember the equation completely, all right. Mechanics, I am teaching step by step. Right, mass into velocity. Mass into velocity. Velocity. Mass is measured in kilograms. Velocity measured in meters per second. M is manual. See, I have maintained a kind of gap between kg, a base unit, meter, a base unit, again a gap between meter and second. Don't write like this kg, m, s, minus 1. Don't write like this, they don't give marks. This idea. That's it. Now, sir, why did you categorize derivatives into three categories: compound names, special names, and compound special name? Look here. Now, these derived physical quantities, area, volume, velocity, acceleration, density, momentum, the units are only derived from the basic units. No, kg. No, all these units are only having basic units. Are there any unit above, beyond these basic 7 units? No. That's why we are calling all these units as derived units with compound names. Right? All the units of these derived units are having the basic units, no? M, S, kg. Therefore, we are calling them as derived physical quantities, derived units with basic units. That idea. Okay. Now we'll do a small question. I think we learned today somewhat, some level, right? Normally we are doing class for 3-4 hours, sometimes 1.5 an hour. In the beginning, it's okay. We'll do a question. I think page number 4 is done. We'll do a question. Go to the page number. Right, page number 15. Go to the page number 15 and start doing question number 1. Find the units and dimensions. You don't find dimensions, only find the units. Find the units of the physical quantities shown below. Now there are 22 equations. Today we'll do that question as our last question for the day. Right, then once we completely discussing the question, it will be 9:30. Then we can stop the class for today. Right, start doing that question number 1. I think we learned something today. Next day we are learning more things, and mostly don't worry, in the next month, April first week, we are starting unit 2, vectors. Right, I'm completing units and dimensions and error section if it is possible. Right, in April I'm starting measuring instruments along with unit 2. Right, and also one thing I will tell you that now don't you misunderstand based on what you learned. You don't come to a conclusion that this is how physics is going to be hereafter. No, it's completely wrong. Right, when you consider 11 units in your syllabus, I don't know why they have given unit 1, units and dimensions. That is one of the basic and really learn by heart unit when you compare with other 11 units. Right? If you want to learn real physics, it is starting from unit 2 mechanics. Really interesting lesson. Right? You can learn everything with the right logic, crystal clear explanations. Really superb unit. Mechanics, the largest lesson in your syllabus is mechanics. You can learn nicely. Right? So then this is not the physics. This is also kind of physics only, but it's very basic ideas, no? Units, dimensions, not big deal. April onwards you will understand how physics is going to be. Don't worry, it's not difficult. Very interesting. Right? Not like chemistry, not like biology. It's really interesting subject. If you're really ready to work with me unconditionally, right, you can experience different stories. Okay. Now start doing the question. Starting page number, go to the page number 15. Now we'll do question number 1. Start doing. Now you guys can do. But what you want to remember is, you must remember 7 basic units and its SI units and 2 supplementary units and its SI units. You must remember those. Right. Page number 15, question number 1. Start doing. Find the units of those given physical quantities. Give a try. So then page number 15, question number 1. Page number 15, question number 1. Start doing, get the answer. Get the answer now. Area means length into width. I just now explained the units of area, but it's okay. Once again do it. Once again find the units of area. Area means length into width equation. Number 1, area means length into width. Number 1, area means length into width. Right. Number 1, write down area. That equals length into width. Length into width. Then what is the SI units of length? That is meters. That is meters, simple limb, into width is also a length. SI units of length, width is also simple limb. Meters into meters going to be meter squared. Meter squared, clear. Number 2. Likewise, keep on doing. You guys can do, keep on doing. Don't waste your time, keep on doing. Number 2, write down velocity means displacement over time. Velocity means displacement over time, the equation. Velocity means displacement over time. Displacement over time. What is the displacement is also a length. Then what must be the SI units to measure the length? It is measured in meters. Simple limb over time is a basic quantity. It is measured in seconds. When the second, simple is at the denominator, goes to the numerator. What is the power of the second? The power of the second is 1. When the second s to the power 1 goes to the numerator, it becomes s to the power minus 1. It becomes s to the power minus 1. Therefore, we can write down velocity means, remember, meters per second. Meters per second. Number 3. Keep on trying. I'll give some time, keep on trying. Just put some thumbs, put some thumbs, give us some time, give us maximum, no time is 9, 10, give us maximum 5 minutes time, we'll complete this question, put some thumbs. If you require some time to complete these equations, put some thumbs. So give us 5 minutes, we'll do these questions and then you discuss. Keep on doing. Keep on doing. Now, if you need some time, please put a small thumbs. Give us some time. We are doing and then discuss. Just give me a small thumb. Just give me a small thumb. Put a small thumb. Now you can do, I think, any question you can do. Just keep on trying. And if you want to clarify any doubt, you can reply to that WhatsApp number. Anytime you can put a WhatsApp message. Right then, if I'm free, definitely I'll respond to your message. Right? Okay. So next one. Okay, next one. The next one is number 3 is acceleration, velocity over time. Number 3, we all know acceleration. Acceleration equation is velocity over time. Velocity over time. Then just now we found the essence of velocity meters per second. Then velocity unit is meters per second. Meters per second. Time is measured in seconds. Simple is. Again, the power of the second at the denominator is 1. When this s to the power 1 goes to the numerator. When this s to the power 1 goes to the numerator, it becomes again s to the power minus 1. Right? S to the power minus 1 into s to the power minus 1. S to the power minus 1 into s to the power minus 1. Remember, we can add these powers together. Minus 1 plus minus 1 is going to be minus 2. Then we are writing the acceleration units must be m s to the power minus 2. M s to the power minus 2. This idea. Number 4. Number 4. The fourth one, what is fourth one? Fourth one is force is mass into acceleration. Fourth one is mass into acceleration. Force equals what? Force equals mass into acceleration. Acceleration. Then mass is measured using kilograms. Simple K, simple G. Into acceleration means what is the essence of acceleration? I found right now. Acceleration essence is going to be m s to the power minus 2. M s to the power minus 2. Then we can write down essence of force going to be, remember, kg, simple K, simple G. Keep a small gap between G and simple M. You can keep a small gap between M and S minus 2. kg, M is minus 2. kg, M is minus 2. Right? Then question number 5. Number 5 you can write down. Number 5. Number 5, that is pressure equals force over area. Pressure equals force over area. Let's find the units of pressure. Pressure that is equal to force over area. Force over area. What is the essence of force? kg m s to the power minus 2. kg m s to the power minus 2 is the pressure in force units. Area measured in meters squared. Area measured in meters squared. Units of area meters squared. Now look here. Now how we going to simplify? Pressure means force over area. Essence of force is kg m S to the power minus 2 over area means meter square. Then we know, look here, we know, right, one simple limb cancel out. If I expand this meter square, look here, kg m s minus 2 meter square means we all know that simple m into simple limb. Meter square means we can remember simple limb into simple limb. When one simple limb cancel out, the remaining is one simple limb at the denominator. If it goes to the numerator, it becomes m to the power minus 1. Because why? Power of the simple limb is 1. As simple limb to the power 1 goes to the numerator, as simple limb to the power 1 goes to the numerator, it becomes simple m to the power minus 1. Then we can write down, if simple m to the power 1 goes to the numerator, it becomes simple m to the power minus 1. Then we can write down kg m to the power minus 1 s to the power minus 2. This is the units of pressure. Right? The way I think idea is clear. If you have doubts, you can ask. Next one. Question number 6, density, mass or volume. Question number 6, density means mass or volume. Question number 6, density equals mass or volume. SI units of mass, that is simple K, simple G, kilograms over. SI units of volume is meter cube. We found velocity, volume, volume already we learned. SI units of volume is meter cube. When m to the power 3 at the denominator goes to the numerator, what will happen? When m to the power 3 goes to the numerator, it will become m to the power minus 3. Then we can write down units of density going to be kg m to the power minus 3. Kg, keep a small gap, m to the power minus 3. SI units of density going to be kg m to the power minus 3. Question number 7. Number 7. You guys keep on trying these questions. Number 7. Number 7 idea. Number 7. Don't waste your time. Now time is 9:20. We'll complete this question and we'll stop the class for today. Right? Can't we take Newton for force? It's right. Still we are talking about derived units with compound names. Right? So therefore, yes, it's correct. You can use Newtons as the units of force, but don't write that story right now. Okay? So using the basic units, find the units of given physical quantities. Okay, we can use Newtons, but I will tell you that comes under derived physical quantities, derived units with special names. Okay, Newton idea comes derived units with special names. We'll talk mostly next day. Keep on doing. Don't waste your time. Keep on doing somehow. Keep on doing. Right? Don't waste your time. Sometimes you guys feel like, these are very basic things. No, why want to put this much of effort and why we are learning? No, never think like that. Right? Sometimes we people ignore some lessons just because they are easy. Not like that. Never think any subject is easy or any subject is difficult. Always learn from every subject. Okay? Right, question number 7th one, work done equals force in displacement. Question number 7, we all know work done. Work done means we can write down work done means force into displacement. Work done means force into displacement. What is the units of force? Just now I found units of force. SI units of force is kg m is minus 2. Kg m s to the power minus 2. Kg m s to the power minus 2 into displacement unit is what? Meters. And now what you can do, see? Now you can see m to the power 1 into m to the power 1. Remember, then if they are the same base, you can add their powers. m to the power 1 into, remember, m to the power 1 into m to the power 1 is how much? You can add their powers. 1 plus 1 is 2. Therefore, we can write down units of work done is kg. M to the power 1 into m to the power 1 is equal to m to the power 2. In case if you are not that much good at adding the powers, multiplying the powers, don't worry. We are doing in our foundation that maths program. S to the power minus 2. Clearly? Question number 8. Number 8. Number 8. Question number 8. 8th one, power equals energy over time. Power equals energy over time. Power equals energy over time. SI units of energy I found that is how much? kg m to the power 2 into s to the power minus 2. kg m to the power 2 into s to the power minus 2 over time is measured in seconds. Simple is. The power of second is 1 when s to the power 1 when s to the power 1 goes to the numerator. It becomes s to the power minus 1. Already there is s to the power minus 2. So s to the power minus 2 into s to the power minus 1 going to be how much? Minus 2 plus minus 1, minus 3. Minus 2 minus 1 is, remember, you can add these two powers. Minus 2 minus 1 means, remember, that is minus 3. Then remember kg m squared s to the power minus 3. Question number 9. We can write on ninth one. Ninth one. Just tell me, are there any students who completed till 15? Put a small thumb. If there are students who finished doing till 15, put a small thumb. 15. Till 15 I done. Till 15, if you've completed, put a small thumb. I completed till 15. Anyone? I completed till 15. Anyone? Right, I think some of you might have finished also. I'm assuming like that. Till 15 finished, there is one. There are some, no? Very good. Very good. Right? There are some people finished till 15. Right? There are some people finished doing till 15. It's good. There are people. There are lots of people are there. Right? Good, good. Keep on doing. Keep on doing. Nice. Keep on doing. Keep on doing. So I'm doing ninth one. Ninth one is we know ninth one is frequency equals 1 over time. Frequency equals 1 over time. Ninth one we know frequency. Frequency equals 1 over time. 1 over time. Then 1 over time is measured in seconds. Simple is power of simple s is 1. When s to the power 1 goes to the numerator, it becomes s to the power minus 1. The answer is, remember, frequency essence is s to the power minus 1. 10th one. The 10th one is torque equals force into distance. Perpendicular distance to the force. That means torque means, remember, force into perpendicular distance. Same story, same idea. Torque equation. Torque equals force into distance. Perpendicular distance only, but we'll write like this. Force, essence of force, I wrote kg m squared into, essence of force I wrote kg m to the power s ni, kg m into s to the power minus 2. kg m s to the power minus 2 into distance is measured in meters. Then we can see there is one simple limb, its power is 1, and this simple limb also has a power 1. Then you can add their powers, 1 plus 1 is 2. Therefore, the units of torque is also kg m squared s minus 2. 10th one. Keep on doing. Keep on doing. 11th one, 11, 12. 11, 12, 13. Right, 11, 12, 13. Starting 11, 12, 13. Starting 11, 12, 13. Question number 11. Question number 11. Surface tension means force over length. Surface tension means force over length. Surface tension, remember, surface tension equals force over length. SI units of force equals kg m s to the power minus 2 over length is in meters. Then we can cancel out the simple limb and simple limb. We can cancel out simple limb and simple limb. Then we are getting SI units of surface tension equals kg s to the power minus 2. Question number 12. Question number 12. Question number 12, 12th one. Young's modulus means force into length over area into change in length. Young's modulus equation. Young's modulus force into length, force into length over area into change in length. Now, some people has a problem, some students has a doubt, sir, what is the units of change in length? Is it meters or something else? Some students have a doubt. Change in length. Now remember now, force is, what is the essence of force? We know, now we can remember also, now we can learn by heart. Kg m s minus 2 is the SI units of force into length is measured in meters, area m squared, meter squared, into, remember, change in length is also a length. Remember the story, change in length is also a length. Therefore, what is the essence of change in length? That is also meter simple limb. Other when you cancel out the simple limb and simple limb, when you cancel out, and also you can cancel out this simple limb with one of the simple limbs. M square means what? M square means you all know that m into m. Then this simple limb cancel out with one of the simple limbs here. Then only remaining is simple limb as the denominator. Then if you move the simple limb to the numerator, it becomes simple m to the power minus 1. It becomes simple m to the power minus 1. Finally, you can write down the units of Young's modulus is going to be kg simple m to the power minus 1, simple s to the power minus 2. Clear, no? Clear. Question number 13. 13. People who finished till 20, I think some of you have a problem with question number 14 because you might don't know the units of viscosity because you don't learn viscosity in your O levels. So therefore, other than question number 14, remaining all the till 22 I completed, put a small thumb. Other than question number 14, viscosity units I don't know. Other than 14 till 22 I completed. I am done with questions till 22. Just put a small thumb. I am done with till question number 22. Put some thumbs. So that I'm doing question number then 13. 13 means Volume means length into width into height, a meter cube, no? So volume unit is, we all know that volume equals length into width into height. Directly I write down units of volume is meter cube, length into width into height. Therefore, meters into meters, it's going to be, power is 1 plus 1 plus 1, 3. The total power is going to be 3. Simple, m to the power 3. Likewise, 14, you have no idea about viscosity. You don't know the units of viscosity. So we'll discuss 14 after complete discussing remaining questions. Now, in case now, okay, we'll discuss 14 later. Okay, 14, you guys don't know the units of viscosity. Therefore, you guys might struggle to find the units of coefficient of viscosity in question number 14. Therefore, just skip 14 for now. We'll do 15 to 22. 15 angular velocity means velocity over radius. 15. Angular velocity means velocity over radius. Angular velocity. This equals velocity over radius. Velocity over radius. Now radius is also a length. What is the SI units to measure the length? Meters. Velocity is measured in ms minus 1, m s to the power minus 1 over radius measured in meters. Simple m cancel out. Angular velocity going to be s to the power minus 1. S to the power minus 1. Question number 16. 16, angular acceleration means acceleration over radius. Angular acceleration means, remember, acceleration means acceleration over radius. Acceleration over radius. Radius time is 9:30. Summer will complete the question and will end the story. Acceleration is what? That is m s to the power minus 2. Radius means meters. Then again, simple cancel out. Units of angular acceleration is s to the power minus 2. S to the power minus 2. Question number 17. 17 going to be what? 17 is a momentum means mass into velocity. Momentum means mass into velocity. Momentum equals what? Mass into velocity. Mass into velocity. The units of mass is kilogram, simple kg. Velocity measured in meters per second. Units of angular velocity going to be, momentum going to be kg m s to the power minus 1. 18. Question number 18. That is inertia means mass into distance squared. Inertia. 18 inertia. That equals mass into distance square. Mass is measured in kilograms. Distance measured in meter squared. Kg m squared. 19 is Planck constant means energy over frequency. 19 Planck constant means, remember, energy over frequency. 19 Planck constant. That is what? Energy over frequency. Now today I am doing a bit hurry. Normally I give some time you guys to try. Normally I am giving time. Normally I am giving time and you guys should do the questions. Even though it's online class also, I'm giving enough time to try the questions only I'm doing, but today we are doing somewhat hurriedly, right? We took already in 9:30, no? Okay. So energy over what? Planck constant means energy over frequency. Energy over frequency. Energy over frequency. Energy units, if you can remember, we wrote, just go and check what is the essence of energy, kg m squared a to the power minus 2. Right? Kg m squared a to the power minus 2 units of energy over. What is the units of frequency? We found the units of frequency also. Frequency unit is going to be x to the power minus 1. S to the power minus 1. Then what happens? Then what happens? Look here. In the numerator also, there is s to the power minus 2. The denominator, there is s to the power minus 1. When s to the power minus 1 goes to the numerator, it becomes s to the power plus 1. Am I correct? When s to the power minus 1 goes to the numerator, it becomes s to the power plus 1. Then now, the numerator, there is s to the power minus 2 and s to the power plus 1. The result is what? Minus 2 plus 1. It's going to be minus 1. Minus 2 plus 1 means it's going to be minus 1. Therefore, we can write down when this s to the power minus 1 goes to the numerator, it becomes s to the power plus 1. Minus 2 plus 1 means minus 1. Therefore, we can write down kg m squared s minus 1. Simple, ni? Simple. 20. Now, question number 20. Last 3, ni? Last 3. Question number 20, last 3. Last 3. Velocity gradient means change in velocity over distance. Velocity gradient. Velocity gradient means, remember, change in velocity over distance. Remember, change in velocity is also the velocity. So therefore, what must be the essence of change in velocity? That is also ms to the power minus 1. Ms to the power minus 1 over distance measured in meters. Then simple cancel out. The units of velocity gradient going to be per second. Per second. Per second. Per second. Then pressure gradient means change in pressure over distance. Pressure gradient, that is what? Change in pressure over distance. Pressure gradient means, remember, change in pressure over distance. Twenty-one, pressure gradient. Pressure gradient equals change in pressure. Change in, remember, change in pressure is also the pressure. Pressure, change in pressure over distance. Now you found the units of pressure. Kg, units of pressure is, you can remember, kg m to the power minus 1 s to the power minus 2 over distance is measured in meters. When simple lim goes to the numerator, it becomes simple m to the power minus 1. Why? Because when the simple lim is at the denominator, the power of simple lim is 1. When m to the 1 goes to the numerator, it becomes simple m to the power minus 1. Then in the numerator there is already simple m to the power minus 1, and here is also there is simple m to the minus 1, simple m to the minus 1 and simple m to the minus 1. You can add them together, the powers. Minus 1, minus 1, minus 2. Minus 1, minus 1, minus 2. Therefore, finally we can write down kg m to the power minus 2 s to the power minus 2. 22, the last MCQ, last question. Last question. Last question for the day, last question. Gravitational constant means force into distance squared over mass squared. Look here. A gravitational constant. Gravitational constant means, remember, force into distance squared, distance squared over mass squared, mass squared. What is the units of force? kg m s to the power minus 2. What are the units of distance? Distance measured in meters, meter square. Mass is measured in kilograms, kilogram square, kilogram square. Then you can remove 1 kilogram from 1 kilogram square, means remember kg into kg. Then 1 kg cancel out. Then when the simple kg goes to the numerator, it becomes kg to the power minus 1. No? If the simple kg the power is 1, if the simple kg to the power 1 goes to the numerator, it becomes kg to the power minus 1. And also there are two m to the power 1 and m to the power 1 into m to the power 2. You can add their powers. 1 plus 2 is 3. kg m to the power 3 s to the power minus 2. Done and dusted. Right? This is the idea. This is the idea, right? I think today we started doing the lesson. Sometimes I don't know how many of you feel like session is not very interactive. I don't know. Just give us more feedback. But generally, now we are doing the classes, online classes via the Zoom chat. So then rather than students asking doubts, students asking their problems, if they don't understand, most of them, they don't like to put in the YouTube chat, right? Because some students, they feel very uncomfortable. They think like their doubt is valid, or their doubt is very foolish. Some people think like that. Therefore, I don't know how many of you experience, even though it's your first day, some of you might experience, even though you want to ask some doubts and you could not ask your doubts, completely all right. Right, most probably from next week or the other week. From that, we are doing only through the Zoom only. Then you can only directly, you can personally, you can put your doubts via the Zoom chat. So then normally I read your doubts. Normally in our class, in our online class, we are just referring your doubts, we are just replying, responding your questions, and only we are doing our online classes. That's the way. And also normally I give some time to practice these questions also by your cell phone. But I don't know how many feel the session is very interactive or not, I don't know. But next week also I might do via the YouTube, and the other week onwards I am doing the class via only the Zoom. So therefore don't worry, right? Our online class is very most effective online class, right? Very effective and very interactive class in the online also, right? If you have anything to be clarified, you can reply to that WhatsApp number. If you want to ask something, you can reply to that WhatsApp number, and also give me small feedback whether you understood or not, if it is possible in your end, whether how was the first day. Last week we didn't do any classes, today only we started the lesson, right? How was the first day, and you understood a lot too. If you didn't understand something, then what are the sections? And you can put a small feedback also if you have time. Really better if you have time. Really better if you have time. 14 question. Okay, we'll do 14 question also. Okay, we'll do 14 question also. 14 viscosity idea. Look here, viscosity idea. Now some of you might don't know the viscosity idea. No, viscosity idea. Look here, viscosity idea. The equation to find the viscosity is, remember, now F equals, we have to learn one equation. Now you don't want to bother this equation. X equals 6 phi eta RV. Right? From this equation we can find the units of viscosity. Viscosity means, remember, viscosity means force over, right, radius into velocity. You don't want to bother with this equation. Viscosity means force over, right? Okay. Okay, now they mentioned there in that right, coefficient of viscosity, right? What shall we do now? We'll neglect that question. This is the equation. Viscosity means force over, right, radius into the velocity. But we'll neglect that equation because you don't have any idea about the viscosity, and therefore it's completely all right. Right, okay, right, that is the story. Okay, then I think just put a small feedback better. If you can put a small feedback better, right, you can put my WhatsApp number. And I think then we are starting next week. We are completing unit section completely. completely we are finishing unit section, and next week if we have time we are starting dimensions. Dimension section is somewhat difficult than unit section. Then mostly from the first week of April I'm starting unit 2 mechanics, and parallelly we are doing measuring instrument section. Right, all the tubes will be posted from the April onwards. If some students they require these printed tubes, then you want to put a personal request. Okay, that is the way. And I think everything is effective. So I will tell one story. Learn everything properly. Okay, try to learn everything properly with me from ground level to top level. Learn, then only you can start thinking. But don't worry about the subject. This subject, don't worry, because I'm an engineer. You all know that. So therefore, we have oral exposed to this lesson and all. We know how to teach you. That idea we know, right? So don't worry. You follow the way that we show. Only follow the way that we show. Definitely, you can go to a good result. Then that idea is finished. Then story finished. No, okay. Then we'll meet on next week. No, not next week. So Friday we are starting kind of. Maths foundation session, 1 hour session, just teaching some maths ideas. You know, you learned in all levels. But once again, I'm revising in that Friday class. Then we'll meet on Friday. Okay. Then we'll stop the class for now. Then good night. Good night and study will. Okay. Refer what you learned. Refer what you learned once again and study will. Okay. So then I think session is finished. Okay. You can ask doubts via the WhatsApp. So then good night.